recording. Okay, let's practice a little bit. Two problems similar to the thing we were doing last time. And after I explain the new part for today. Okay, suppose this operation. 2 parentheses cosine pi over 10 plus I sine pi over 10 and everything raised to the fifth power. To the fifth power. I recall the formula. Recall formula. For the Mobi theorem. The formula say, so you have, for example, one complex number, r cosine I sine theta, and you raise to the n power. You raise to the n power the r part cosine I sine, and you multiply by n the angle. Bang! This is the formula. Okay, let's apply the formula in this particular example. S2 to the fifth power, because the R is 2. Remember, this is notation, you could put acronym cosine, que sí, I, que es the imaginary unit, no? And sine of pi over 2. This is the acronym, no? Some book don't like this, but I like this. Entonces, cosine I sine, pi over 10 multiplied by 5. Entonces, 5 pi over 10. Make sense? Make sense?
Yes.
Now, wait, simplification. Bueno, 2 to the fifth power es obvio que es 32. Because 2 times 2 times 2 times 2, 5 times is 32. Cosine I sine pi over 2. Because when you reduce the lowest term divided by 5 is 1, divided by 5 is 2 is pi over 2. Okay, leave it like that. Well, you can. Of course, this is correct. However, more elegant is, well, you expand. You put 32 parenthesis cosine pi over 2 plus I sine pi over 2. Yeah, I know by memory que cosine pi over 2 is 0 and sine pi over 2 is 1. The answer then is 32i. Wow. And it's logical because when the angle is pi over 2, remember the famous complex plane. This is the real axis and this is the imaginary axis. And suppose one complex number can lie exactly on the imaginary axis like that. Look, let me show you. Here. And the angle is 90 degrees. Pi over 2. This is pure imaginary. This is logical que es pure imaginary. Pure imaginary number que es 32. So the distance is 32. In what direction is over? Because it's positive. Make sense?
Yes.
Okay. I bring another example. That was example 1 for today. Example 2 for today is, okay, this is one bracket, 1/2. We have cosine 72 degrees plus I sine 72 degrees. And raised to the fifth power again. I suppose that the complex number is given in polar form. Polar que es R, polar. Polar is, you know, is R cosine I sine theta. So I did the job. Because normally in college algebra we don't know that. In college algebra you know the standard. The standard que es x plus I y, no? This is the standard. You don't know trigonometry in college algebra. So now the trigonometry open the door to see another point of view of the complex number, que es polar form. It's a rectangular form. And it's a polar. En polar, sometimes no. Some operation is easier. Okay, because you are doing algebraically, it's too long and complicated. Entonces, using the same formula is 1/2 raised to the 5th power cosine I sine 72 multiplied by 5. So 5 times 72 degrees. Okay, 72 times 5, 360. Uy, 360 degrees. 360 degrees is 1 revolution. Entonces, well, you erase this. This is 1 to the 5th power is 1, 2 to the 5th power is 1 over 32. Entonces we have cosine 360 degrees. Do you understand where I come from? 360, no? What's the multiplication? 5 times 72, no? Plus I sine 360. Bueno, cosine 360 es 1 and sine 360 is 0. Because 360 is equal to 0 degrees. It's 1 revolution. Entonces, the number is 1 over 32. We have no imaginary part. We have only real part. Entonces, it's obvious. Look, this is my real plane, real axis, imaginary axis. See, the angle is 360 degrees. 360 degrees is this angle. That means that our complex number lie, boom, here. It's obvious. Well, the magnitude of this is 1 over 32. I don't care. This is not important. The important is the angle. And you see that this is purely real. Purely real number. Purely real. When the angle is 0, purely real. When the angle is 180, it's purely real, pero negative. When the angle is 90 degrees, it's purely imaginary, like that. When the angle is negative 90 degrees or 270 degrees, like that, it's purely imaginary, but in opposite direction. Suppose negative 32i. It's clear? It's clear or confusing? Very, very confusing or very, very clear? A ver, it's clear, okay? Okay. I understand. So you say, I believe. Okay, now let's move on to the root. Okay, I never seen before in my life. Root of the complex number, root. And we start the motivation example, root. Motivation example, que is, suppose que I want to compute root, but what kind of root? Square root, cubic root, any root. So motivation example is square root I. I never see before in my life. It's possible, Professor? Yeah, it's possible. Square root I, I see, and when the professor in college algebra explained the power of I explain I to the second, I to the third, I to the fourth, or I to the -2, or I to the -3. So in this case, it's a integer number, right? No, never decimal. Never. Actually, this is I raised to the 1/2 power. Wow, what the hell is that? I don't know anything. Okay, but we can using the polar form. And okay, let me try it. Suppose that I have no idea. One student in college can do that. Yes, advanced student maybe yes. Okay, how? Well, I have no idea. Square root I. Suppose that I don't know polar form. I only know rectangular. X plus IY. So my goal is find X and find Y. Because actually I know it's complex, no? It's complex number. So if you square both sides, you have I, because a square root and a square power undo each other, and you expand this guy. You foil. If you want foil, the student can prefer foil. It's not using foil. They are twin brothers, no? Is x squared Plus I x times y plus again I x times y. They are twin brothers, it's obvious. Plus the last case I square y square. So I need to know que I square is -1. I suppose you remember this, no? Well, no, it's not hard. What is the definition for the I? Definition for the I is I alone is definition is square root -1, ¿no? Entonces I square is square both sides es -1. Unbelievable. I is imaginary, pure imaginary, and I square no. I square real. Okay? I remember in college algebra this. Okay, entonces I alone is equal x squared. Entonces this is -1. Entonces x squared minus y squared plus 2 times I xy. Because they are this and this together is lighter combined. So when you compare this expression and this expression, I realize that this complex number is just I, it's pure imaginary. That means that the real part is 0. So now this is the real part. Look, this is the real part. And this is the imaginary part. Let me use another color. So now I see clear like water. Okay, x squared minus y squared equals 0. Because we have no real part in this number. In conclusion, x squared equals y squared. In conclusion, x equals y. Wow. The thing I try to find is x and y is the same. However, in the imaginary part, is the green part, this is +1. Plus. Don't confuse. The coefficient is 2xy equal 1, no? Because here the coefficient is 1. I is this I only put equal each other 2xy equal 1, get the coefficient here in the front. Therefore, say I know that x and y is the same according to this idea of substitution in this system. 2x and times x, because y and x is the same, equal 1. X squared equal 1/2. Therefore, x is equal square root 1/2, que es square root 1/2, que es plus or minus radical 2/2. So you rationalize, blah, 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 blah. So now the final answer is the square root I is radical 2/2 plus I radical 2/2, nice. But we have two solutions, one positive and one negative, no? And negative radical 2/2 minus I radical 2/2. Right? This is the way that one advanced student que take algebra can solve in this problem. And for example, cubic root or 4 root is crazy. It's not impossible, but it's too hard doing it in that way. However, the motivation is that I try to explain one formula, Mobi Formula, one formula that is possible to do this job in 1 second, directly. Okay, the most important is, look, this is my famous complex plane. Real axis, imaginary axis. The location of this solution is radical 2/2, radical 2/2 is here. Look. So you are doing in the polar, okay, I know very well that the angle is 45. This is cosine, I sine, 45 degrees. Yes or no? Because x is this, so this is cosine, theta, this is sine theta. R is 1, it's obvious is 1. And the angle is 45. So we have here, let me call Z null as the first solution. C null, twitch. And we have another solution. This is C null, and C1 is exactly the same solution, but opposite side. This is opposite direction like that. C1. The angle here is 45 degrees. Let me do a sketch again. Because I put together here, it's crazy. Okay, this is 45. I call C null. Okay, and C1 is exactly the same, except que the sign is negative. Okay, entonces D es cosine I sine 225 degrees in the third one, C1. One geometry picture of this idea is imaginary axis, real axis, sorry. My real axis. Imaginary axis. This is here, over there, C null at 45 degrees. And C1 is completely opposite direction. C1 is 225 degrees. Okay, this is the polar representation of the solution of the square root I. Another approach. What is the Mobi formula? The Mobi formula say in polar. Okay, formula for the square root or for the any root. M root in polar. Okay, we have a complex number in polar. R cosine I sine theta. And you apply n root. In our particular motivation example was a square root. The square root, the index of the root is 2. And normally default, you don't need to write 2. And when it's QE, yes, your specification, but no. And the formula say you compute the n root of the R part, cosine I sine, and you take theta, is the angle, plus 360K, I want to explain what is that, divided by n. Okay, you can using that formula in degree, or you can use that formula in radian like that. It's similar. Cosine I sine theta plus 2k pi divided by n. In our specific example, the square root I, que was the motivation example, es obvio que n es 2, look at that, invisible 2, and es obvio que the radio R is 1 because I is a complex number, pure imaginary number, real axis, imaginary axis. The I is just I here. This distance is 1, radius 1, and the theta is 90 degrees. So basically, the representation in polar of I is cosine I sine 90 degrees. And you apply the formula. The formula says square root 1, es obvio que 1, cosine I sine 90 degrees plus 360 K, I don't explain who is K. This K and this K is the same K. I want to explain now, divided by 2, because the index is square root is 2 divided by m, que es 2. And who is K? Well, K is a natural number, no natural, whole number. It starts in 0, 1, 2, 3, and so to n minus 1. In this case, in this specific example, in the first example, que n is 2, so you are doing only K0 and K1 because stop in n minus 2. See, n is 2, 2 minus 1 is 1, so you evaluate n0 and you evaluate 1. And this is exactly we expect because remember you have two solutions, C0 and C1. It's important to understand that when you compute the square root of any number, we have two solutions. When you compute a cubic root, you have 3 solutions. When you have 4 root, you have 4 solutions. And the solution is given by k. You start 0, 1, 2, 3, until n minus 1. So 1 multiple number less than the original index of the variable k, in this case 2. But well, let's finish this example. Okay, suppose k is 0. Suppose k is 0. Well, k0 is, well, square root 1 is 1. You know, cosine I sine. This is 90 degree plus 0 divided by 2. A 45 degree. Wow, look at that, 45 degree. 45 degree. 45 degree is exactly the same C0. C0. Ajá, entonces, bueno, son estudiantes. Bueno, profesor, pero I don't like. I like manipulating polar. Pero the final answer, no, I don't like expressing polar. Because I don't understand very well. Okay, no problema. No problema. You put cosine 45 degree plus I sine 45 degree. I know very well que dice radical 2 over 2 plus I radical 2 over 2. Boom. And we get the answer. This is C null. And K equal 1 is the second solution, que es cosine I sine 90 degree plus 360 under the supposition que K is 1. 1 times 360 is 360 plus 90 divided by 2. Then you put in the calculator 360 plus 90 degree, okay, is 450 divided by 2 is the famous 225 degree. Cosine I sine 225 degree. Bueno, leave it like that. Yeah, you can. Professor, I don't like this. Okay, no problem. We put cosine 225 degree plus I sine 225 degree. Yeah, I know que cosine and sine 225 degree is the same value of the 45, but opposite, because 225 lie in the third quadrant. In the third quadrant, cosine and sine both are negative, and the answer is negative radical 2 over 2 minus I radical 2 over 2, que corresponde perfectly with the solution C1, que the students que don't know polar and doing using Golden algebra idea. This is sophisticated student, no? Nobody understands this. Get the sense. Do you follow me? Do you understand the idea?
Yes, I understand. But I was we need to just put the values on the calculator, right? For example,
yeah, of course. The arithmetic part, I don't care. You put nuela, you put 360 plus 90 divided by 2, 225. Entonces now, or you know by memory, cosine 225, or you see in the unit circle. I don't care that. Okay? You ask me specific the arithmetic part or the trigonometry part?
I asked both because I would like
well, the arithmetic part, calculator. It's obvious, right? And trigonometry part, well, you need circle.
Okay, Professor, I got you. But for when we are using the formula, so we need to solve we need to find the 2 solutions or more, right?
Or more. You see now, example, get 4 root, 5th root, and 4 we have 4 solutions, and 5th root you have 5 solutions, and so on. Okay.
Okay. But with the formula, it's easier. The other one was.
See, the formula is easy. The formula is easy. It's only the formula is easy. Okay, I have one third example. Let me see. Okay. One nice example. Look. Suppose compute example 3, no? 4 root of 1. Bueno, professor, 4 root 1 is 1. But you say, professor, okay, we have 4 solutions, no?
Yeah.
Entonces I need to find the 4 solution using the formula. Let me copy one more time the Mobi formula. The Mobi formula says n root of the one complex number, que is r cosine I sine theta, is equal. I dedicate only the n root of the r part cosine I sine theta plus, let's do it using degree, que es dice 360k divided by m, right? Okay, entonces the first job is expressed one like a complex number. One is a real. Okay, one is 1 plus 0i, no? So you want to apply the formulas that you know very well. R is equal to square root x squared plus y squared, and theta is tangent inverse of y over x. This is the formula that allows conversion from rectangular to polar. Nice. However, this is pretty easy in the intuition. Look, this is the complex number, this is the real axis, and this is the imaginary axis. And I know one, sorry, no, one is here. I put like a vector, look like an arrow, but the arrow is not important. In order to identification what is the start point and what is the ending point, ¿no? Entonces put the arrow, ¿no? To indicate que es in that direction, pero no necessary. Entonces es possible apply the for root of the one complex number, que the R is 1 cosine I sine 0 degree. Do you understand this idea?
Yes, but we can also find with the formula, right, Professor?
No, because I know by memory que si es real, suppose 1, suppose negative 1. Es the same as 1 cosine I sine 180 degree. When it's 180 es negative 1. Suppose que es I, entonces es 1 cosine I sine 90 degree. And suppose que es negative I, is 1 cosine I sine 270 degree, or whatever you want, negative 90 degree. 1 cosine I sine negative 90 degree. Remember, we can measure the angle counterclockwise or clockwise. It doesn't matter. O sea, no fórmula. Professor Anthony Esposito here. Apologize. No problem, Anthony. Personal issue. Okay. Do you follow me so far?
Yes, Professor. So it means that is 1 because on the graph the distance is between 1.
Yes. Suppose que I change, Nuela. I put 100 here. 100. Suppose 100. 100. For 100. To say 100 here, 100 here, 100 here, 100 here. So the distance is 100 of the complex number. Make sense?
Yes, it does. Thank you.
Okay. Oh. Okay. Let me erase everything. This is confusing. So my problem was easy. This is for root of the 1. One is cosine I sine 0 degree. Correct? Yeah, I omit this one. This one not important. Because when it's 1 multiplied, it's invisible, no? Okay, basically it's a for root cosine I sine 0 degree. One more time, I copy the formula for the Mobi. It's general, super general for any root R cosine I sine theta is equal n root of R cosine I sine theta in degree or radian, either way, 360k divided by m. And who is k? Okay, it's a whole number que start in 0, 1, 2, bam, and ending in n minus 1. In this case, in our particular example, we are doing example 3, k is 0, 1, and 2, no? Because the index of the root is 3, no, and 3, sorry. Okay, n is 4. So it's 0, 1, 2, and 3. N minus 1. Make sense?
Yes.
I set up. I put 4 root of 1 is over 1. Cosine I sine 0 degree plus 360, k divided by 4. Okay. Too much complication. I want to simplify a little bit that. Look, for root 1 is 1, it's obvious. Entonces cosine I sine. 0 is nothing. Entonces 360 divided by 4 is 90. 90. Okay. Make sense? 90k.
Yeah.
You have like K0. Bueno, K0 es cosine I sine 0. Que es cosine 0 plus I sine 0. Cosine 0 is 1. This guy is 1. And this guy is 0. 0i. It's logical. The answer que any student que don't know trigonometry is 4 root 1 is 1. Because you multiply 1 times itself 4 times. 1 times 1 times 1 times 1. Obviously the answer is 1. Yes or no?
Yes.
What about k equal 1? K equal 1 is different. It's cosine I sine is 90 degree. Because 1 here is 90 degree, no? It's a cosine 90 degree plus I sine 90 degree. Pero cosine 90 degree es 0 and sine 90 degree is 1. Entonces the answer is I. Wow. It makes sense. Si you multiply I 4 times is 1. I have no idea. Let me try. I times I times I times I is I to the 4, no? Y I to the 4 is 1. You remember college algebra? Or no? Well, I prove for you. I prove que any... You remember or you don't remember?
A little bit, Professor.
A little bit, no. Yes or no? Yes or no? Remember or don't remember? Two options, 50-50. No, a little bit, ambiguous. Okay, you remember that I squared is negative 1? Or no? This is clear for you, right?
I do, yeah.
Entonces, I times I is negative 1. I times I is another negative 1. And negative 1 times negative 1 is positive 1?
Yes.
Clear? Okay.
Yes.
I suppose that the teacher, I suppose that it was me, no?
No, Professor, it was another one.
Another teacher.
I was your student for other class.
Okay, I is I. I to the second power is negative 1. I to the given power is negative I. I to the fourth power is 1. And this idea repeated again 4 by 4. To the fifth power is I. To the sixth power is negative 1. To the seventh power is negative I. To the eighth power is 1. And so, this is the power of I, idea in college algebra. Okay, entonces I to the fourth power for sure is 1, no? Okay, yes. I finished. No, we have 4 solutions. Okay, equal to the cosine I sine 180 degree. Yes or no? Because 90 plus 2 is 90. Entonces cosine 180, plus I sine 180. Okay, cosine 180, I know by memory que es negative 1, and sine 180 is 0, and the answer is negative 1. And this answer makes sense or no? If you multiply negative 1 4 times by itself, the answer is positive 1 or no?
Yes, it makes sense.
Negative 1 times negative 1 and negative 1. So we have actually even number negative, the answer is positive 1. And the last one is k equal 3, que es cosine I sine, and this is multiplication by 3 is 270 degrees. Entonces cosine 270 degrees plus I sine 270 degrees. Cosine 270 degrees is 0 and sine is negative 1. Entonces the answer is negative I. Wow. Entonces actually the solution of the 4 root of 1 is 1, it's obvious, is I, it's obvious, is negative 1, it's obvious, and negative I. And so you are doing graphically to see the relationship. Look, this is the real axis. This is the imaginary axis. Let me use another color. One here, I here, -1 here, and negative I here. All we happen, guys, okay, we have the circle, 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 circle. Well, depending the radius of the circle, no? In this case, 1, because the number 1, see, the number is another number, entonces the circle is no 1. But we have 4 solutions, entonces 360 divided by 4 is 90 degrees. So the angle in between the solution is 90 degrees, and this specific example because of 4 root. A 4 root. A little bit confusing or a little bit clear?
It's clear.
It's clear. Okay. I have another example. Okay. 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 Another example. Suppose this example. Let me see. Okay. This is beautiful. I like that. Okay. Suppose compute. Compute. Example 4, no? Cubic root. Cubic root of 1 plus I. Wow. Look like weird, huh? 1 plus I. Okay. And to say one more time, I copy the formula. Mobi formula is m root r cosine I sine theta is equal root m of r cosine I sine theta plus 360, okay, divided by n. Okay. So what should I do first, in your opinion? What should I do first? Well. What should I do first? Well, the first step is conversion. 1 plus I, que is the complex number, and rectangular converted to polar. So from conversion from rectangular to polar, no? Okay, entonces now this is easy, or relatively easy to see. Let me show you. In the complex plane, look. This is real axis, this is imaginary axis. 1 is here, 1. And I is here. And together, this is the complex number. Okay, this is Z. And see the R value is a square root, so the R is a square root x squared plus y squared. In our specific example, x is 1 and y is 1, que is the coefficient here, que is invisible, of course, 1, is square root 1 squared plus 1 squared. Is radical. Super. And the angle, not necessarily trigonometry to understand that theta is 45 degrees. Just in case, you put a formula, no? Theta is equal to tan inverse y over x, in our specific example is 1 divided by 1, que es 1, y tan inverse 1 is pi over 4 or 45 degrees, either way, and degree or radians. Okay, so I immediately understand that this computation is a cubic root of the radical 2 cosine I sine 45 degrees. Make sense or no?
It does.
Step number 1 is conversion, because my formula is created to receive a complex number in polar. See, my original problem, the complex number is given a rectangular, entonces I need to do the process of conversion to polar. Okay, no problema. Now, I put together, entonces now is square root, no, cubic root, sorry, of 2 of the square root. Wow, what the hell is that? Cubic root, square root. Oh, well, it's easy. This is 6 root. Makes sense or no?
It does.
Sense? Yeah. Cosine I sine, cosine I sine, cosine I sine. And the angle is 45 plus 360 multiplication by k divided by 3, que es the original index of my problem. Okay, entonces now I need space to compute this, it gets a little bit long. Boom. Y I doing for different k0. So my k and the formula for the specific problem is 0, 1 and 2, no? 1, 2, 3 solutions. And start always in 0. Entonces, for k equals 0 is 6 root of 2 cosine I sine 45 degree. Because k0, that part is 0, it's gone, right? And this is 45 divided by 3, get 15, sorry, 15 degree. Oy. This is 360 k. Si k es 0, entonces 45 divided by 3. Entonces radical 6 root, sorry, of 2 cosine I sine 15 degree. Okay, this is the answer in polar. If you want the answer in rectangular, well, okay, we can do that. This is radical 6 root of 2 cosine 15 degree plus I sine 15 degree. And 15 degrees is no fundamental angle that you memorize in the unit circle. But you can use in the calculator. Okay, entonces I use in calculator. I don't want waste time with this. And the answer is, final answer 1.08 plus 0.289i. So I put in the calculator sine 15 multiplied by this, cosine 15 multiplied by this. I get the answer. This is stupid arithmetic, no? I'm using calculator. And k equal 1. Okay, equal 1 is 6 root of 2 cosine I sine. And you have 45 plus 360. I suppose k is 1 divided by 3. Entonces I put in my calculator 45 plus 360 is 405 divided by 3 is 135. Cosine I sine 135 degree. Okay, 135 is the fundamental angle, but it's okay. You put in the calculator, the answer is negative 0.79 plus 0.79 I.
Professor, sorry, I'm just wondering, like, this says, like, if you had that option in the calculator, because I couldn't find on mine.
Well, so you leave it like that in the test. It's okay. Everyone understand. But I try to explain, maybe in your future work, you don't need this, or the teacher or the subject you are working. You need the complex number and the rectangle to say you conversion. But this is easy. The conversion from polar to rectangular is piece okay for you. It's a long process, no? So you need to differentiate what is the easy, what is the complicated, or what is the long or short. It's long, and we use in calculator, of course, because 15 degrees, I don't have idea what is the sine and cosine of this guy. But the calculator understand very well this. Okay? Noela, it's okay?
It's okay, Professor, because I was just wondering because I don't have that option on my calculator.
And for k equal to, we have the same r value, cosine I sine 45 degree plus 720. Where come from 720? Well, no, it's 360 times 2 because k is 2 plus 45 is 795 divided by 3 is 265. 265 or 345? Let me try again. 45 plus 720 divided by 3. 255. Entonces, 6 root 2 cosine I sine 255. If you need, this answer is perfect. However, if you need decimal approximation, you put in the calculator. But you put in the calculator, how? When you put 6 root of 2, cosine 255 degree, que es no fundamental angle, es crazy angle, plus I sine 255 degree. I put in the calculator, that's it. The answer is negative 0.79 minus 0.79. And we expect, of course, 3 solutions of this 3 solution. Any question?
I have a question. Okay.
Go ahead.
No, Professor, I was just wondering. First, we need to find the graph, the values. Then we can determine the values, right? For example, yeah. This is my question.
Come on, finish. For example, what?
No, Professor, I was just giving an example. For example, this graph. First, we saw on the graph that it was like 1 in 1. Then we.
Well, the graph is totally optional to understand the geometry interpretation of this. But no. It's computed the cubic root of this complex number. So the thing is, you need to understand that we have 3 solutions. Number 1. And number 2 is that the 3 solutions form a circle. By the way, the radius of this circle is, this number gets 6 root of 2. And it's expand 15 degree, 135 degree. So the first solution lie in the first quadrant, the second lie in the second quadrant, and the third lie in the third quadrant. And it's totally similar to the flower like that. No flowers, star like that. Ting tang. And the angle is the same. C0, C1, C2. This 0 is K, K0, 15 degree, 135 degree, and the 255. But this is complementary. It's not exactly the most important idea. Okay, one more example. I have 3 more examples. Remember, one formula and several examples to understand the idea. Suppose I need to compute 4 root of negative 16. Wow. I have no idea. Intuitive is no easy to see. What should I do first? Guide me. Help me to understand this. Is we are expecting 4 solutions. Yeah, absolutely perfect. 4 solutions we expect. So what should I do? To solution, okay, solutions, yes. What should I do to apply my famous formula? What is the formula I need to apply? This formula, one more time, I write r cosine I sine theta is equal n root of r along cosine I sine theta plus 360k divided by n. In our specific example, n is 4, right? Then what should I do? Step 1, step 1, step 1, step 1. What should I do? What is the step 1?
We need to find the values of x and y, Professor.
No. This is the last step. This is not the first one. The last step is find x and y.
But I mean, we need to graph, Professor. We need to, because you got giving like examples with the graph. You graph first and then we find the values.
Oh, but okay. You are right. However, you express it wrong. Okay, the thing you try to explain is that you need to convert -16 to polar. Yes or no?
Yes, Professor. Yeah.
Entonces, you propose me doing graphically. Okay, I understand. Nice for you. This is the real axis. This is imaginary axis. And I know very well that -16 is a number here, right? Yes or no?
Yes.
And the magnitude of this, I call vector, but actually it's no vector, is 16. So R is 16. And what about data? Look at the picture. What about data?
Theta is positive 16 as well?
No. Who is theta? Theta is the angle measured from the real axis. Okay, let me do a sketch for the elementary or general cases. General case is, look, we have the axis. This is the complex number. This is theta. The angle measured from the real. Okay, it's equivalent to the x-axis. And the y is the imaginary. Not exactly, but to have geometric idea. So what is the angle of this vector? Okay, it's pointing completely in opposite direction to the left of the real axis. What is the angle? Not necessarily Nuela. Any student can have idea can help me, no? Or nobody have idea. So I total loss?
Yeah.
Oh. And you want to take calculus? Ay. Okay. Let's do it together. You help me. Suppose one complex number in that direction. This is real. This is imaginary. What is the angle of this? In the same direction, in the positive direction on the real axis. 16.
Yes.
What is the angle? It was my question. The answer is no, yes or no. I need information. What is the angle? It's important that you understand this. This is a central idea for this. No the formula. No.
Can we use the formula, Professor?
My question is, forget about this problem. Forget about everything. Forget about everything. Suppose that this is my famous axis, real and imaginary. I suppose that I touch this. One complex number here, que the magnitude is 16. What is your representation in rectangular and what is the representation in polar? Well, in rectangular is 16 plus 0i because we have only component in the real axis and we have no component in the imaginary axis. And the representation in polar is R is 16 cosine I sine 0 degree. Because what is the angle formed between real axis and this vector, red vector? It's 0 degree, right?
I see. Okay.
Suppose another vector here, and this is 45 degree. This is another idea, right? Pero no. Suppose now, another example, in which is completed, imaginary, 16i. What is the representation of the rectangular? Non-real and 16i. And polar, 16, que es the same magnitude. Cosine I sine, 90 degrees. Boom. Because the angle is 90 degrees. Make sense?
Yeah, it does.
Okay. Now, let's continue. Exactly our problem I try to solve it. You don't help me. It's negative 16. It's real. So the negative 16, I want to continue here. Is minus 16 is the real part and no complex, no imaginary, sorry, part. Entonces now the representation is 16 cosine I sine 180 degree because that angle is 180 degree. Make sense or no?
No, Professor, can you explain again?
What part you need can I explain?
I didn't understand why it formed an angle.
Do you see that the green vector is in the opposite direction to the red vector?
Yes.
And the red vector, the angle is 0 degree, and the green vector is opposite, 180 degree.
Okay, I see. Okay.
Okay, don't try to see beyond this. It's elementary idea. Suppose that we have now another vector. Let me use gray color, que es pure imaginary, like that, que es minus 16i. Entonces, this vector have no real part, and the imaginary part is negative in the opposite direction. The representation in polar, this is polar, this is rectangular, is 16. Do you see that the radius is the same because the radius is the distance from the pole to the arrow. Es cosine I sine 270 degrees. ¿Qué es this angle? Look. Whoa, 270 degrees. Oh, another tú dices, no, I don't like 270 degrees. Okay, no problem. You write 16 cosine I sine negative 90 degrees. ¿Qué es this angle? Y es equivalent. The only difference is que I measure counterclockwise or clockwise. Either way you want. Are you clear?
Yes.
Okay. Let's see. You're clear. We come back to our famous problem.
Sorry, before we go, I just have one question. If this one is 270, that one can be negative 90 or 360?
200. These are equivalent expression. You want I show you?
Yeah.
Okay, look. Suppose 16, parenthesis, cosine 270 degrees plus I, sine 270 degrees. And my goal is proof that this is equivalent to say 16 cosine negative 90 degrees plus I, sine negative 90 degrees. Okay, this is 0. This is 0. And this is negative 1. And the answer is obvious, is negative 16i. Because we have no real part. And cosine 90 degrees, it's 0. And doesn't matter if it's positive or negative because cosine is even function. And this answer is 0. And this is also negative 1. Boom, same answer. Okay? Beautiful.
I got it. Thank you, Professor.
Okay, entonces now practice. And this problem I tried to do was, okay, by the way, I don't remember what's the number, but this is not important. Example 4, no? Is 4 root of negative 16. What is the first step that you should do to apply this formula? Que es fantastic. Maybe you don't like, but I love you. Okay? Okay, it's cosine I sine theta plus 360, okay, divided by m. It's a Mobi formula. Okay, and what should I do? It's ready to apply? No. Why no? It's not ready because negative 16 is rectangular. It's a pure real number, right? However, I know very well okay, this is equivalent to say 4 root 16 cosine I sine 180 degree. Make sense now or no?
Now it does. Thank you.
Okay, super. Now the rest is using the formula, and this is 4 root of 16 cosine I sine. Entonces es 180 plus 360k over 4. In our specific example, no?
Yeah.
Uh-huh. Well, 4 root 16 is 2. It's obvious, right? This is 2. This is 2. Cosine I sine. And k equals 0. K equals 0. It's obvious que 180. Divided by 4. Because k is 0, that part disappears, right? Entonces 2 cosine I sine. And 180 divided by 4 is 45 degrees. Okay? And you can live like that. Everyone understand very well in the world. See, in one application, you need express this complex number from polar to rectangular. Okay, no problem. Is 2 cosine 45 degree plus I sine 45 degree. Yeah, I know very well que es radical 2 over 2, but this is extra. I radical 2 over 2. And 2 is cancelled when you multiply distributing. Entonces, the answer is radical 2 plus I radical 2. But this is equivalent to this, 100%. Polar, rectangular. Make sense?
Yes.
For a moment, to don't complicate the arithmetic part, leave it like that. And it's okay. It's equivalent. K equal 1. It's 2 times cosine I sine 180 plus 360 divided by 4. Entonces, I put in my calculator, 180 plus 360 is 540 divided by 4 is 135. Entonces, this is 2 cosine I sine 135 degree. It's possible to change to this? Of course it's possible. It's very, very similar. Let's do in curiosity. Why not? It's 2 cosine 135 degree plus I sine 135 degree. And you know 135 degree is the angle in the second quadrant here. Okay, the reference angle is 45 degree. So it's the same value of the 45, but you adjust the sign. And the second quadrant, the cosine is negative, because it's negative radical 2 over 2. Y sine is positive, radical 2 over 2. When you multiply by 2, entonces the answer is negative radical 2 plus I positive radical 2. Boom. My second solution. Everyone follow me so far?
Yes.
Okay. K equal to is 2 cosine 2 cis. 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 180 plus, bueno, 360 times 2, que es 720 over 4. Se pone en el calculador. 180 plus 720. Well, it's 900 divided by 4 is 225. 2 cosine I sine 225 degrees. Okay, is equal to cosine. This is extra. Si you leave it like that, it's perfect. Answer 1, answer 2, answer 3. and polar. Cosine 225 degree plus I sine 225 degree. In this case, both are negative, no? Negative, the same value, negative radical 2 over 2, negative radical 2 over 2. Entonces the answer is negative radical 2 minus I radical 2. Okay? And K equal 3, que is the last one, no? Because we have 4 solutions. It's 2 times cosine I sine 180 again, plus 360 times 3. And 360 times 3 is 1080 plus 180 is 1260 divided by 4, 315. 2 cosine I sine 315. 315 is similar to cosine 315 degree plus I sine 315 degree. In this case, the cosine in the 4th quadrant, 315 lie in the 4th quadrant, no? Is positive, radical 2 over 2. And this is negative, negative radical 2 over 2. The answer is radical 2 minus I radical 2. Okay, we found the 4th solution in polar, 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 look, polar, 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 and polar, and rectangular. Rectangular, 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 and rectangular. See, we're doing quickly, no, to the graphic. It's not important, but it's a curiosity, you know. The graphic look like that. Okay. The first root is 45 degrees. And this distance is 2, guys. This distance is 2. ¿Qué es this? Look. This number. And the angle is 45 degrees. And you project it here. This is real. This is imaginary. Es obvio que that distance is radical 2. And that distance is also radical 2. Make sense? More clear now or no? Wow.
Yes.
Fantastic. 45 degrees. And where's the next guy? 135 degrees. Guess this. This is Z0 because was at K equals 0. C1. Okay, C1 is 135 degrees. And the real part is negative. Look at that. Radical 2. But the imaginary part is positive. And this is C2. C2 is at 225 degrees here. 225 degrees. Negative both. And C3 is positive, the real part, and negative, the imaginary part. Super fantastic. Yes or no?
Yes, it is, yeah.
So stop here. We finished that part. Is the application for the polar and complex number. We study how we convert. We study multiplication, division, power, and root using complex number and polar form. Okay, now Thursday we start the last topic. It's interesting. It's about vectors. It's a little bit complicated. Okay, guys, too much for one day. Bye bye.
Tomorrow, are you gonna be on the Turing section, right, Professor?
Yeah.
Okay,
Tomorrow.
Cool. Okay. Bye-bye, Professor. Have a nice day.